You walk through the door, your cat looks up, just for a second, before it decides whether to care. In that second, you wonder what it's actually seeing. A companion? A servant? Something to tolerate until dinner? Or maybe, to a creature built for hunting, you're just prey that got too big to catch. You will never get to ask it directly. But here's the strange part. Someone already has. For decades, researchers in ethology, comparative psychology, and cat-cognition have been quietly chasing this exact question. Real labs, real studies, not internet theories. And the answer they've found isn't any of the easy guesses you already believe. Let's name the guesses first, because you've probably made all three. Guess 1. Your cat sees you as a food dispenser. Warm-blooded, mildly useful, replaceable. But cats form real social bonds, recognize your voice and your name, and read cues that have nothing to do with dinner. That's not what a food dispenser gets. Guess 2. Your cat is just aloof. Doesn't care either way. The behavior says otherwise. Greetings, scent marking, seeking you out. Cats built to be indifferent don't do any of that. Guess 3. The flip side. Your cat loves you exactly like a dog does. Also wrong. Comparative studies put dogs and cats through the same tests, and dogs are just easier to read, better at following a pointed finger, more willing to even finish the experiment. Cats aren't failing to be dogs. They're running a completely different social system, not like a dog. So what does the real research actually look like? For a long time, scientists just assumed cats weren't that social. Not compared to dogs, not compared to primates. That assumption turned out to be wrong, or at least incomplete. Reviews across animal behavior journals now describe an entire dedicated field. Cat-human relationships, attachment, social signaling. We just weren't looking at cats the right way. Part of the problem is cats themselves. Put a dog in a lab, and it performs. Wants to. Tries again if it fails. Put a cat in the same lab, and it might just leave. Walk off mid-experiment. Sit down, stare at the wall, which means fewer usable trials, smaller sample sizes, and a much slower science than the one built around dogs. That's not a flaw in cats. It's a mismatch between the test and the animal. Here's the deeper reason why testing cats is so different. A cat's whole social world was built for something else entirely. A colony of other cats. Status, scent, space, who gets close, who doesn't, who ranks where. None of that was designed with humans in mind. It evolved for cat-to-cat life, long before any cat ever lived in a house. So when your cat looks at you, it's not inventing a new set of rules. It's running the only social software it has. That software has a name, and a scientist who spent decades decoding it. John Bradshaw, an anthrozoologist at the University of Bristol, spent years just watching cats. Not testing them, watching them. In his 2013 book, Cat Sense, he lays out a theory that reframed how we think about cats entirely. Bradshaw argues cats mostly don't build a new set of behaviors just for us. Instead, they run their ordinary cat-to-cat behavior on you. To your cat, one theory goes, you're not a separate category of being. You're a larger, non-hostile cat, just a bigger cat. That's Bradshaw's read, an interpretation built from decades of behavior, not a direct line into a cat's mind. Worth holding loosely, but the behavioral evidence behind it is real, and it's specific. Start with the tail. Straight up, sometimes curled slightly at the tip, like a question mark. In 2009, researchers Cafazzo and Natoli filmed cat colonies and clocked exactly when that tail up appears. It shows up as a greeting, most often from a lower-ranking cat approaching a higher-ranking one. It's a cat's way of saying, friendly, no threat, coming in close. That exact posture, tail up, walking straight at you, is the same one your cat uses on you. Then there's the rub. Cheek against your shin, head against your knuckles. Cats do this to each other too. It's called allo-rubbing, and it mixes their individual scents into one shared smell. One study found 83% of cats rub against their owner the moment they're reunited. Same posture cats use in a greeting. Same rub cats use to bond. Just aimed at you. So maybe you really are just a very large, very slow cat, as far as your cat's concerned. But that theory has a problem. It doesn't explain everything cats do when you're not even in the room, because treating you like a cat doesn't fully cover what happens when you leave. In 2019, researcher Kristen Vitale ran an experiment borrowed from a very different field, infant psychology. It's called the Secure Base Test. Originally built to study how babies bond with parents, later adapted for dogs. Vitale and her team ran it on cats. Briefly separate them from their person, then bring the person back. Watch what happens. Published in Current Biology, the results looked almost identical to what researchers see in human infants. Around 64 to 65% of both kittens and adult cats came back to their owner and settled, a pattern called secure attachment. The same rough percentage as securely attached babies. as securely attached dogs. 64% secure. It's one of the most quoted findings in this entire field. And it deserves a caveat right alongside it, because 4 years earlier, a different team ran a similar looking test and found the opposite. In 2015, Potter and Mills tested 20 cat owner pairs with their own version of the same setup. They found no strong evidence cats were using their owner as a secure base at all, just more vocalizing when the owner left versus a stranger. That was about it. 2 careful studies, 2 different protocols, 2 different answers. And nobody's run Vitale's exact version again yet at scale to see which one holds. So file this one as real, promising, and still genuinely unsettled. We'll come back to why that matters later. Let's get more specific. How does a cat know it's actually you, not just a stranger who wandered in? Start with your voice. In 2013, Atsuko Saito and Kazutaka Shinozuka at the University of Tokyo played cats recordings. 3 strangers' voices, then the owner's. The owner stayed hidden the whole time. Only the voice was real. Of 20 cats, 15 stopped reacting to the repeated stranger voices, then snapped back to attention the moment their owner's voice played. Ears turned. Heads moved. A clear, measurable response. What they mostly didn't do was get up and come see who it was. Recognition. Without a reaction, you'd actually notice from across the room. It gets more specific than voice alone. In 2019, Saito's team tested whether cats know the sound of their own name. Not just any word, their name specifically. They played a string of similar sounding words, then the cat's actual name, even spoken by a total stranger. Cats reliably picked it out, every time. Proof they discriminate their name sound from everything else. They know their name? That's not the same as understanding a name the way you do. Not a label yet, as far as anyone's proven. Just a sound they've learned to isolate. Cats living in cat cafes, surrounded by dozens of names, called constantly, were actually worse at this. Too much noise, not enough consistency. Later work found cats can also learn the names of other cats in the house and match familiar people to their faces, at least in a lab setting. And it's not only sound. In 2021, researchers found cats build something like a mental map of exactly where you are. Play your voice from the wrong corner of the room, somewhere you shouldn't be, and cats visibly startle. Their own map got it wrong. Somewhere in all of this, recognition stops being just about sound and starts being about something underneath it. They know your voice, they know your name, but what they're really building underneath all of it is something you can't even hear, something you can't hear. It's what you smell like. A cat's nose isn't just better than yours. It's operating on a completely different scale. Estimates put it somewhere between 150 and 200 million scent receptors packed into that small face. 150 million receptors. You, for comparison, have somewhere around 5 to 6 million. That gap works out to a sense of smell estimated at 14 to 40 times more sensitive than yours. There's more. Cats have a second smelling organ entirely, tucked into the roof of the mouth. You've seen it work without knowing it. That odd, open-mouthed grimace cats make at a new smell. It's called the Flamen response. That organ is built specifically for reading pheromones, the chemical signals of who's who socially. 30 versus 2. Cats carry roughly 30 of the receptors used to tell individual scents apart. You carry about 2. So when your cat presses its cheek against your leg, that's not random affection. It's depositing its own scent from glands on its face and reading yours right back. Cat colonies build something called a colony scent. One shared smell that says, you belong here. You're one of us. Every rub against your leg is your cat folding you into that smell, marking you as theirs. To your cat, knowing you was never really about your face or even your voice. It's about how you smell, and that you smell like home. Zoom out for a second. Why does any of this exist at all? The answer is buried in how cats were domesticated in the first place, and it's a very different story than the dog one. In 2007, geneticist Carlos Driscoll analyzed 979 cats and traced domestication back roughly 9,000 to 10,000 years to the Near East. Cats weren't bred by humans. Not at first. They domesticated themselves, moving in around early grain stores, hunting the rodents that came for the harvest. Later, ancient DNA work traced them spreading with humans out of the Near East and Egypt. But almost none of that spread involved humans selectively breeding cats for behavior, not the way we shaped dogs. Dogs got thousands of years of us picking the friendliest, most biddable ones to breed. Cats mostly didn't, which means a lot of what reads as independent in your cat is just undomesticated in that specific sense. But something else happened instead. Cats stayed partway kittens for their whole lives. Take the meow. Adult cats almost never meow at each other. Meowing is a kitten sound, a kitten calling for its mother. Somewhere in domestication, adult cats kept using it. Just redirected at us. Still a kitten. Every meow for food, for attention, for the door to open is a grown cat still speaking kitten. Then there's kneading, paws pressing rhythmically into a blanket, into your lap. Kittens do this against their mother's belly to help her milk flow. Adult cats keep doing it anyway, on the people and places that make them feel safest. Put it together. Rubbing that shares scent. Meowing that's really a kitten's call. Kneading that's really a nursing reflex. Your cat isn't just treating you like a big cat. Part of it is still treating you like a mother. Now the honest part. Because a video like this can make it sound like the science has all this figured out. It doesn't. Cat cognition research is genuinely young. Smaller studies, smaller samples than dog research gets. Partly that's the field's fault, partly it's just cats, they walk out of experiments, they refuse to cooperate. Remember those 2 attachment studies? The ones that disagreed with each other? That's not a flaw in the science. That's what real science, still in progress, actually looks like. 2 careful teams, 2 different protocols, 2 different results. And nobody's fully repeated either one at scale yet. Still unknown. The honest answer is, we don't fully know yet how deep cat attachment goes. And that's fine to say out loud. Here's another one worth sitting with. Researchers found that how attached a person already is changes how many emotions they see in their own cat, independent of what the cat is actually doing, which means some of what you feel your cat feeling about you is also you projecting onto it. Even Bradshaw's big idea that your cat sees you as a giant friendly cat isn't a direct readout of a cat's mind. It's an interpretation, a well-supported one, built on real behavior, but an interpretation. None of that makes the findings worthless. Voice recognition is real, name recognition is real, some form of bonding is real. It just means the full picture is still being drawn, and you're watching that happen in real time. So here's the twist waiting at the end of all this. What looks like your cat ignoring you might be the opposite. It might be your cat already answering. In 2020, a team at the University of Sussex tested something almost too simple to be real science: the slow blink. A human looks at a cat, narrows their eyes, slowly, holds it, releases. Cats blinked back, more often than chance, and they were far more likely to approach the person who'd blinked at them over one with a flat, neutral face. The Sussex team has a name for it: building rapport. A real conversation in a language you already have access to, not aloof, tail-up greetings, rubbing that shares scent, a slow blink across a room. All of it a vocabulary, just not one anybody taught you to read. So next time you walk through that door and your cat looks up at you for 1 second before deciding whether to care, try slow blinking back. It might already be answering the question you walked in with. And once you start noticing that language, the tail, the rub, the blink, you start noticing something else too. The moments your cat is speaking and nobody's listening, because that same quiet vocabulary has a warning folded into it. The signals right before a happy, purring cat suddenly turns and bites the hand petting it. That's not betrayal. That's the same language gap with sharper stakes. It's exactly what I covered in my last video. Check the pinned comment.